Unit 10 AP exam review questions. So these are the problems worked out. Which of the following is the sum of the series? Well, if we're adding it up, it's geometric. So what are we multiplying by each time back and forth? It's a geometric series, so what's the R value? So we look up here, and we could rewrite this as pi over e squared. Careful now, to the n, meaning we're multiplying by pi over e squared, which is 3.14 over 2.71 squared. All right, we can sum it up. First term, plug in 0, it's 1. 1 over 1 minus pi over e squared multiplied by e squared over e squared ends up with e squared over e squared minus pi. Hey, check it out, I got it right. That's always fun. Assume f has derivative of all orders for all real numbers, which follows third order Taylor polynomial. Well, they give us f naught, f prime of naught, f double prime, and f triple prime. And then this is where I always really have to slow down and make sure I get that right. So if I recall correctly, a third order polynomial would be 2 plus negative at 0, negative x, negative 1x, plus 6x squared over 2 factorial, plus 12x to the third over 3 factorial. So that's 2 minus x plus 3x squared plus 2x to the third. 2 minus x plus 3x squared plus 2x to the third. If you can do that, you're in good shape. Which of the following is the Taylor series generated by f of x equals 1 over x at x equals 1? So this is tough. I don't know what they're asking. I usually don't. And then I think 1 over x, I can probably do this with my derivatives, or I can do it a different way. Well, I'll always do derivatives because that makes sense. F of 1, we're doing 1 this time, is 1. F prime of x is negative 1 over x squared. F prime of 1 is negative 1. F double prime of x is 2 over x to the third. F double prime of 1 is 2. Might as well go for one more. Negative 6 over x to the fourth. F triple prime of 1 is negative 6. So knowing that, we go p of x, I don't put a number here because we're doing all of them, is 1 plus negative x plus 2x squared over 2 factorial plus negative 6x to the third over 3 factorial, dot, dot, dot. So it's an alternating series where we go, oh, and I blew it. Oh, that's so upsetting. Fix it. X minus 1. X minus 1 squared. X minus 1 to the third. Notice how easy it is to forget that extra little piece of the puzzle there. So there's an alternating piece and there's nothing on the bottom. So almost want to start canceling things out here. No, no, all right, could be no, no. So that leaves us with E. I have done this in the past before where I say, this is the same as 1 over 1 minus x. 1 minus cancels, 1 minus x becomes positive. There's my f of 1 of x. But that just confuses me, so I don't even know if I recommend this. So that would be 1, and then it's plus. Let me think about this. 1 minus x. Yeah, but I need this as x minus 1. So how do I make this x minus 1? 1 over 1 plus x minus 1. Let me think that makes sense. Those cancel, I'm left with x. Yeah, that also works. Which would be 1 minus, because this is minus minus, x minus 1 plus x minus 1 squared minus x minus 1 to the third, dot, dot, dot. I don't know if that's such a good idea, but we get the same answer. Which of the following series converge? And you got to be quick at this. Yes. 2n over 3n is 2/3 the n. Yes. Root 4n over n will give me 1 over n to the 3/4, if I'm not mistaken. So that's a no. So that means 1 and 2 only. Following the sum of the telescoping series. By the way, I've never seen telescoping series on the AP exam. I mean, it's kind of cool, but it really doesn't matter. So we do this nonsense. 2 equals a over n plus 1 plus b over n plus 2. And my brain was just on full alert there going, what just happened? I did something very wrong. 2 equals a times n plus 2 plus b times n plus 1. N equals -1. See ya. A equals 2. Yeah. N equals -2. See ya. B equals -2. So let's try it again. Sum of n equals 1 to infinity of 2 over n plus 1 minus 2 over n plus 2. Plug in 1 and we get 1. Plug in 1, we get minus 2/3. Plug in 2, 2/3. Minus 1/2. Plus, plug in 3, 1/2. Minus 2/5. Dot, dot, dot. Cancel, 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 cancel. 1. You know, we're never going to have that on an AP test, but that's just cool math. You should be proud of yourself if you can do that. Which of the following best describes the behavior of the series? Blah, 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 blah. Well, n grows faster than ln of n. But if there was no alternating series, this would not converge. It does converge, but it converges conditionally. So that's going to be 1 and 3 only. I sure hope you got that conditional stuff down. Let f be the function defined by yada yada on the interval convergence. Hey, interval convergence, how do I do that? Ratio test. Limit n goes to infinity. What's with the 2? 2. Well, I don't like this at all. X plus 2 over 3 to the n plus 1 over 2. X plus 2 over 3 to the n equals x plus 2 over 3. Okay. -1 has to be less than x plus 2 over 3 has to be less than 1. -3 less than x plus 2 less than 3. Yeah, that's 2. -5 less than x less than 1. Okay. Let's check the endpoints. -5 -5 plus 2. -3 is just -1 oscillating back and forth. No. And the same thing for 1. 1 plus 2 is 0. 3 is 1 oscillating back and forth. No. So, what did they ask for? Interval of convergence. There it is. Or -5, comma 1. Onwards, find the function that the series represents. Now, this one just freaks me out the first few times I see it, so don't panic. When it converges, we can just say it's the first term, plug in 0. Yeah, plug in 0, 1. So A0 equals 2. And what are we multiplying by each time? R equals x plus 2 over 3. So the function is 2 over 1 minus x plus 2 over 3. 3 over 3 equals 2 times 3 over 3 minus, careful here, x plus 2. Equals 6 over 3 minus 2 is 1. We'll go with x plus 1. -1. That's embarrassing. 6 over x minus 1. Consider the power series, final values, absolutely, yada, yada. So ratio test. Limit n goes to infinity. N plus 1. 2x plus 3 to the n plus 1. N plus 3. N plus 2. N. 2x plus 3 to the n. Bye. 2x plus 3 to the 1. Now, let's look at this. It's going to diverge at the endpoints because it's got n over n plus 2. I'll check them, but I mean, I know it diverges. So, where were we? -1 less than 2x plus 3 less than 1. Subtract 3, -4 less than 2x less than -2, divide by 2. -2 less than x less than -1. What do they want to know? Oh, guys, absolutely. Yeah, okay. That's it. We're done. I don't have to check endpoints. I only check the endpoints for conditional convergence. All right. All right, so let's go down here and check for conditional convergence. All right. So how would I do this? Sum n equals 0 to infinity. I'm trying to think how I would show this on a real test. 2 times -2 plus 3 to the n over n plus 2 is going to be -1 to the n. Limit as n goes to infinity. No, that's wrong. Is going to be the sum n equals 0 to infinity, cancel, of -1 to the n. Diverges. And might as well be thorough. Let's go with x equals -2, x equals -1, n over 2 times -1 plus 3 to the n over n plus 2 equals sum n equals 0 to infinity of 1 to the n. Diverges. All right. Let f of x equals 1 over x plus 1. Find the first three terms, the general term for the Taylor series. F of 0 equals, whoops, f of 1 equals 1/2. F prime of x equals negative x plus 1 to the negative second. F prime of, first three terms, of 1 equals negative 1/4. F double prime equals 2x plus 1 to the negative third. F double prime of 1 equals, I am going to leave it as 2/8. It equals 1/4, but I think that might be a smart thing to do. So the first three terms, P, yeah, 2 of x, second order, is 1/2, and now that I screwed this up earlier, I hopefully won't do it again, minus x minus 1 over 4 plus, 2/8 x minus 1 squared over 2 factorial. Cancel, cancel, but I'm just going to leave it. I'll write it for the students, but if this was a test, done. I don't actually know if I could leave it like that. I'd have like this disease that would keep me from doing that. Over 8, and then it says the general term. F of x equals sum 0, 1, 2, but that's 1, 2, 3. Yeah, I'll go with 0. N equals 0 to infinity. Got an alternating, negative 1 to the 0, negative 1 to the first, to the n, x minus 1. To the n, over, and I would always write underneath, but I'm running out of space. 2 to the n plus 1, 2 to the n plus 1. 0, yep. 1, yep. 2, yep. Alrighty. Find the interval of convergence for the series. Limit. N goes to infinity. Absolute value, x minus 1, n plus 1. 2 to the n plus 2. 2 to the n plus 1. X minus 1 to the n. Limit. N goes to infinity. We'll have 1 extra 2 on the bottom. We'll have 1 extra x minus 1 on the top. X minus 1 over 2. Find the interval of convergence. I still got to check endpoints. Negative 1 less than x minus 1 over 2 less than 1. Negative 2 less than x minus 1 less than 2. Negative 1 less than x less than 3. Negative 1. Plug in negative 1 up here. I get negative 2 to the n. Pull out the negative part, they cancel. I get 2 to the n over 2 to the n plus 1. I get 1/2. So it diverges. Plug in 3. 3 minus 1 is 2. It doesn't matter. I can't believe I'm doing this. It's 1/2, and it's positive, negative, positive, negative. So it's, yeah, right. Negative 1 to the n times 1/2 also diverges. So interval of convergence. -1, 2, 3. Whew, breaking a sweat here. Find the third order Taylor polynomial for f at x equals 1. Use it to approximate f of 0.5. All right, well, I can just blast out the third order based on what I put up above. I did a second order. Third order is 1/2 minus x minus 1 over 4 plus x minus 1 squared over 8 minus x minus 1 to the third over 16. Now, you might think this is a little bit unfair, and I would agree. This has to be a calculator problem. So we're plugging in P3 of 0.5, and you would get 0.664. Let f of x equal this. Find the interval convergence. So ratio test. Limit n goes to infinity, n plus 1, x to the n plus 1, 2 to the n plus 1, 2 to the n, n, x to the n equals by x over 2. -1 less than x over 2 less than 1. -2 less than x less than 2. Find the interval of convergence. I really got to go check my endpoints. -2 goes in. I get n getting freakishly big, and I'm left with plus or minus 1. No. Plug in 2. No. And on the top runs that. So your interval of convergence is -2 to 2. So the first 9 terms of series sufficient to approximate with an error less than 0.01. Okay, so first 9 terms. We go with, let's see, plug in 0. And we're doing -1. 0. Now plug in 1 with -1 in there. -1/2. Plus, and here we go, 2/4 minus 3/8 plus 4 over 16. So you do that with 9 terms. And you get what you get, but the error will be the absolute value of the 10th terms. This is an alternating series. So error less than or equal to 10 over absolute value, tosses that out. 0, 1, 2 to the first, 2 to the second, 2 to the third, 2 to the 10th, which is 0.0097, which is less than 0.101. This is exactly what you would have to do on a AP free response question. So 75–80% chance you will see that. Let f be a function, derivatives all orders, blah, 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 blah. All right, pretty straightforward linearization. That's the first term. just -1 plus 2x. Quadratic. So that's the second order. -1 plus 2x plus -3x squared over 2. Third degree Taylor polynomial. -1 plus 2x minus 3x squared over 2 plus 4x to the third over 3 factorial. You can be done right there, but you know me, I can't help myself. 2x minus 3x squared over 2 plus, one of the 2's will cancel, be left with 2/3. 2/3 x to the third. Use, oops, sorry about that. Use P3 to approximate f of 7. P3 of x of 0.7 is -0.106. All right, here we go. Mclaren series for function given by yada yada, converges yada yada. Find R. Limit as n goes to infinity. -3 to the n. This one I put inside because there's a negative that'll pop out here. X to the n plus 1. This one I'm not putting inside. N over equals, let's see, that's one less, that's one more, the negatives are gone. 3 absolute value of x. I could have put the 3 inside. Find the blah, blah, blah. Find R. Well, that means that we have, for those that haven't figured it out yet, -1 is less than 3x, is less than 1. -1/3 is less than x, is less than 1/3. That means R equals 1/3. Write the first 4 non-zero terms in the Mclaren series for f prime. It says the first 4 non-zero terms. I don't know what that'll be, so I'll just leave it as. Oh, actually, I do have it up here. First 4 non-zero terms. All right, cool. For f prime, the derivative of f. Okay. So going up top, pulling it down. First 4 non-zero terms. I got next, so I just need the first 4 terms there, which is the third order. No, it's not. It's fourth order. P4 of x is x minus 3/2 squared plus 3x to the third minus 27 over 4 x to the fourth. First, second, third, fourth term, -3 to the third over 4. Yeah, there it is. So P prime, which will be a third degree polynomial. Let's do what they say. F prime of x is 1 minus 3x plus 9x squared minus 27x to the third. So let's see, this is geometric multiplying by -3 every time. Every time they say as a rational function, that means it's geometric. The first term is 1, and the r value is -3x. So f prime of x is 1 over 1 minus 3x. Plus. Write the first four non-zero terms, Mclaren series for e to the x. E to the x equals 1 plus x squared over 2 factorial plus x to the third over 3 factorial. First four 1, 2, 3 non-zero terms. Got it. Use the Mclaren series for e to x, right? Third degree for gx equals e to x times f of x. Third degree Taylor polynomial for g of x. P of 3 equals wow, that's just rude. First non-zero terms. That's part of the problem. 1 plus x squared over 2 plus x to the third over 6 times x minus 3 halves x squared plus 3x to the third. Now that might seem like unfair to blast out all those, but I only have to do the ones I need. So since this is a 1, I need up to an x to the third here, no question about it. They want the third degree polynomial. But once I get past that, I don't have to do all of them. So P3 of x equals x minus 3 halves x squared plus 3x to the third. Now the x, I don't have to do the last one, plus x squared minus 3x to the third over 2 minus 3x to the third over 2. Now this one, I only need the first term plus x to the third over 2. And if you blast that out, you should get x minus x squared over 2. That's a mess, isn't it? Minus 3 has, minus 2 has, plus 2x to the third. And that's it. I don't have to do anything fancy. I don't have to find interval convergence and any of that. No, that's a very typical AP problem. I see stuff like that all the time. They put these two together and ask you to go. I don't usually see the multiplying, so that seemed a little unusual. Taylor series for a function given about x equals 1, blah, blah, blah. Find the value of r. Ratio test. Limit n goes to infinity. Toss that out, it's going to get blasted away. 2 to the n plus 1 over n plus 1. X minus 1 to the n plus 1. N 2 to the n. X minus 1 to the n. Equals two times x minus 1. So now, do I need the interval convergence? No, just the radius. So unfortunately, I'm not smart enough to do this without it. So -1 less than 2x minus 1 less than 1 divided by 2. -1/2 less than x minus 1 less than 1/2. That means the radius is 1/2. Plus 1, 1/2 less than x less than 3/2. So the distance between these is 1, therefore the radius is 1/2. Find the first 3 non-zero terms for the derivative of this nonsense. So I've done this lots of different ways. This seems to make the most sense to students, writing the third order polynomial based on that nonsense up there. Plug in 1, it's even, 2 over 1, x minus 1, that sort of thing. So you get 2x minus 1 minus 4 over 2 x minus 1 squared. Interesting. Plus 8 thirds x minus 1 to the third. Now they want first three non-zero terms. So p prime, which is really wrong, I should say, f prime. And I know it's about 1, you'd still leave that, is derivative x minus 1 is just 1, 2 minus 2 up front, they cancel, 4x minus 1, 3 up front, they cancel, 8x minus 1 squared. First three non-zero terms. Oh, need the general term. So here we go, that's part of it. And then, that's right. General term. Sum n equals 0, infinity, -1 to the n, positive, negative, yep. 0, 2 to the first, 2 to the second, 2 to the n plus 1, x minus 1 to the n. Check it out. Yeah, that should do it. Now let me make sure. 0, yep. 2, yep. 0, yep. Yeah, that works. Okay, Taylor series for f prime by final part B is geometric. So it is. Find the function which series converges to, use function determine f. Okay. Looking up above, I would say my first term is 2. And my r is -2x minus 1. That's weird. Okay. Oh, and then use that to determine f. Got it. Got it. I was trying to figure out what the hell they were asking here. We're finding f prime. So f prime of x equals 2 over 1 minus -2x minus 1. So yeah, equals 2 over 1 plus 2x minus 2 equals 2 over 2x minus 1. Cool. F of x equals the integral. It's really got nothing on it, so we'll just throw it up there without limits of 2 over 2x minus 1 dx, which is the ln of absolute value of 2x minus 1 plus c, but it doesn't matter. Yeah, actually it does matter. It's plus c. Let's see, derivative gone. Derivative 1 over 2x minus 1 times 2. Looks good. How do I find c? X 1. Part B, f of 1 equals 0. Do I know that? X equals 1 from the function which is converged function term for x minus 1 is less than r in the integral convergence. That x equals 1. Well, let's see what we can do. If I plug in 1 here into the for f prime, well, this is the third degree polynomial. If I plug in 1, everything zeroes out, right? So I get 0. All right, I guess so. From, by the way, this is harder than what you would see on an AP test. Part B, f of 1 equals 0. You could even go to part A and say, plug in 1 here, it all vanishes. So 0 equals ln of 2 times 1 minus 1 plus c. And that's ln of 1, which is 0, so c equals 0. Cool. So f of x equals ln 2x minus 1. And that's what they just said here for, remember, it only works on a interval of convergence, which we never figured out. There it is. Woo! Guess that, breaking the sweat here. Functions derivatives for all orders, n-degree polynomial. Known f of 0 equals -4, p1 1/2, show that f prime of 0 equals 2. So let's go find the first, let's go find this nth degree polynomial. F of 0 is -4 and p1 1/2. So p1 is -4 plus, I don't know, f prime of 0 times about x equals 0. X, there's nothing on the bottom. P1 of 1/2 equals -3. So -3 equals -4 plus f prime of 0 times 1/2. At 4, 1 equals f prime of 0 times 1/2. Multiply by 2, 2 equals f prime of 0. Notice the math is not that hard. Understanding what the hell they're asking and how to get there is extremely challenging. All right, so it's known that f second prime of 0 equals 2/3. Find p3 of x. Yeah, I can do that. P3 of x equals -4 plus 2x plus -2/3 x squared over 2 factorial plus 1/3 x to the third over 3 factorial. That is technically done. But hey, I can't help myself. P3 of x, that was weird. X equals -4 plus 2x minus x squared over 3 plus x to the third over 18. Kill. And last but not least, function h has first derivative given by h prime f of 2x. Known that h of 0 equals 7, find third degree Taylor polynomial for h about x equals 0. No idea what's going on. H prime equals f of 2x. All right, so they gave me the first term, they gave me the second one, find that x equals 0. So h prime of 0 equals f of 0. And that goes back up here, is -4, unless I'm very mistaken. And third degree polynomial for h. H prime has first derivative given. -4. Right? Third degree polynomial over h, about that. And so second derivative, h double prime of x equals f prime of 2x times 2. H double prime of 0 equals f prime of 0 times 2, which is 2 times 2, which is 4. By the way, there's a very distinct chance I'm doing this all completely wrong. But yeah, let's see what happens. Yeah, no, I like what I'm doing. What I did last time is not so good. H, I want third degree polynomial. I need one more. Third of x is, holy cow, 2. I'm just putting that 2 up front. F double prime of 2x times 2 again, which is 4f double prime of 2x. H 1, 2, 3 of 0 equals 4 times f second derivative of 0. Did I ever figure that out? Yes, I did. Second derivative of 0 is negative 2/3 equals 4 times negative 2/3, which is negative 8/3. Okay, third degree Taylor polynomial, P3 of x equals 7 minus 4x, about 0. I need to underline these. Plus 4x squared over 2 factorial minus 8/3 x to the third over 3 factorial. P3 of x equals 7 minus 4x plus 2x squared minus 4x to the third over 9. And I'm looking at this, figuring out how I did it last time. I think I just integrated the f of x. Since h prime of x was f of 2x, I plugged 2x in here. So negative 4 plus 4x minus 4x squared over 3 plus 8x to the third over 18. And I integrated it. And it got me here. I had to find a c value when I integrated it, but same thing. That's pretty cool. Good luck. And I always say good luck, but I really mean it this time. You're going to need it.